Welcome back, everyone, to Merge Conflict, your favorite Reacts podcast. Frank, we're doing a Reacts episode.
Oh, finally. I've been begging for this the whole time. We should just turn into a complete Reacts channel. So are we going to watch TV? Is that what we're going to do? Like maybe Arrow season 1. I think we should start with Arrow.
Uh, uh, okay, but is that really what we want? Is Arrow? Really? I mean,
Mm. Can you name better entertainment?
well, you know me, I'm not into the MCU, so we'll carry. I'm just an Iron Man person. That's it. So.
DC, sir.
I'm really not into the DCU.
DCEU? I don't even
DCEU?
know. Instead, let's react to maybe some programmers, maybe something we can actually offer some half decent opinions on versus our. Oh, you would have good opinions on entertainment, but I think we'll do better with programmers.
I try to do. Now I have been, these are like pretty common. I watch a lot of finance videos and people do a lot of react videos to like finance TikToks or YouTubes or whatever. And I know Primogen does a lot of react stuff to like blog posts or other videos out there. A lot of articles, like hacker news articles, things like that. And I thought would be interesting is it's always really fascinating. We record this podcast around like 7:30, 8 o'clock, and it just like went into dark mode. Because I'm one of those people, you know what I mean?
Ooh, yeah.
And I'm always like, what just happened? Did everything just break on my computer? But it didn't. But I figure what we do is there's a little video of our friends over at Fireship, and Fireship puts out videos that get like a bajillion views, right? But I thought this one was fascinating because it wasn't like this programming language, this news, this new thing. Let me tell you, hey, I did blah, blah, blah. It was called 7 Programming Myths That Waste Your Time. And I thought it'd be fun because I figure in the ethos of merge conflicting, the question is, do we merge conflict with ourselves on these topics and or also Fireship himself?
Look, spoilers, but I love this video. This is right up my alley, and we'll get into exactly which video it is and everything, but these are my favorite kind of YouTubes where basically someone just gained a bit of wisdom. And wisdom takes a long time. It's painful. It takes time and pain to gain wisdom. Those, I think, are the only ways you actually get wisdom. And this is one of those things where maybe you won't, I don't know, I never take advice from other people, but maybe you won't have to go through the pain and suffering if you watch these kind of wise videos. Yeah. But this is right up my alley because this can save you a lot of frustration and I want to say time, but really it's just frustration and feeling weird and all that kind of stuff that it can save you from.
And feels, yeah, I agree. So what I want to do is we'll go back and forth. I have the breakdown. I kind of have like the TLDR of each one that Fireship goes into. And then the other, then we'll react. And we'll agree, disagree, and we'll converse on it. It's kind of like a lightning round, actually, you know what I mean? But okay, the first myth, programming myth, is that you need to use the latest tech to stay relevant. Fireship says, the real world where jobs exist, there's a lot of PHP, Java, PostgreSQL, C++. Not everyone, you don't need to chase the fancy new Rust and Next.js and NoSQL databases, right? Plenty of things still running COBOL in the world. And if it ain't broke, don't fix it. So what do you think, Frank?
True and false. I think the overall idea is absolutely correct that you don't need to chase the new technology. If you are a good web developer and you are comfortable writing raw JavaScript with your PHP server, with your MySQL database, maybe Postgres, but why change? Why ever change? Because the beauty of the web is you can run anything on your server, and basically the user doesn't care. As long as the website is running well and you did your good job and everything is secure, it really doesn't matter, especially in the server world. Now, with us being app developers, we're kind of forced into different things because we are at the mercy of the operating system. And operating systems are constantly shifting and changing their requirements. But overall, the idea here, if you get good at something, just stick with it. Why would you ever spend the time to get good at something and then decide not to use that? You're just throwing away those years of wisdom, skill, and basically expertise for absolutely no reason. I think they had the quote that I like the most came out of this section, which
Oh,
is
nice.
it's you can chase any new technology, any new framework, any of that kind of stuff. But in the end, if the user can't tell the difference, then it just doesn't matter. If especially in the server world where you are in control of all the software that's running, man, write that thing and don't write it in C++. Things do improve over time, and that's my half agree, half disagree. Things do
Yeah,
improve over time, but don't throw away your expertise. If you have 5 years expertise in PHP, then write good software in PHP. You can write terrible software in the best programming language, and you can
it's
write
true.
good software in the worst programming language. What really matters is your expertise. And that's where I like this one the most.
Yeah, I agree. I think that the twist of it is like, yeah, you don't need to use like the shiny new thing, right? There's going to be a new JavaScript framework every 5 seconds, so like you don't need to like worry about it. There's going to be new frameworks for just about everything or new libraries. Like if you know it and it works, then it's awesome. Keep going at it. You know what I mean? Like, and I think there's a reason a lot of people ask, oh, I'm using Razor Pages or MVC. Should I keep using that? I'm like, I don't know. Like, are you super good at it? And like it runs and it fits your needs, your business needs. Like, then you don't need to necessarily change that new thing. Like, I do think in the world of C++ and COBOL and things like that, like the hardest part is like if you're a company attracting new people to that technology over time. So there may be
Right.
maybe a need to change some of those methods of what you're creating new while still maintaining. But so I think there's a spectrum that you can kind of go in there. But I agree, like there's a reason that I've been building mobile and desktop apps with Xamarin Forms and .NET MAUI, right? Is like I know I know all it works. I know Xamarin Forms, I know .NET MAUI. It's the same thing. Potato, potato. I mean, it's different, but same enough, right? That I'm not like relearning everything from scratch, like a new thing. I'm like, oh, I want this thing. So I think that's one thing that's been nice as well. But I agree. Like I do think though that the flip side is I would recommend like like knowing what the new tech is and maybe having fun and experimenting from time to time, because that I think is still fun. Like I think that not necessarily need to build production stuff, but like I'm building a Blazor website, like a pretty production Blazor website that we talked about last week. And I'm like
Mhm.
learning a lot. I'm learning how to componentize it. I'm learning how to do like um, different like parameters and bindings and all these things and navigation and these things that I don't do in the world of mobile. And I'm like, oh, like I knew the basics, but I'm kind of going a little bit further just for fun. I mean, Copilot's writing it, but I mean, you know what I mean? Like, I still think it's
Yeah.
still fun to at least know what's happening, but I don't think that's a requirement either. Like, I think there's plenty of
Yeah.
developers that are like, I do this thing and I do this thing, and I think that's totally okay.
And to be blunt, though, that's a very selfish reason to switch technologies. A
Which
good
one?
reason to switch that you're learning and that you're excited.
Oh yeah, I don't think you need to
It's a
switch.
good
I just
thing.
think it's
Yeah.
fun to file new every once in a while.
Yeah, absolutely. And you got to keep your mind. You got to keep learning. Well, I think functional programming kind of fits into a lot of this too. It's the new hotness from every 10 years. Functional programming is the new hotness, and there is a lot to be learned from it. A lot of discipline that you can gain from it. But again, going back to, do your users care? Like, do my users
It's
care
true.
whether iCircuit was written in a functional style? Do they care
No,
whether it was written in Rust?
no.
No, they care about features, stability, performance, things like that. Is it chewing through my CPU? Some things like that matter. So that's why I just said it's a little bit selfish, because if you are if your goal is to write software for thousands and thousands of people to use, then you wandering off into the weeds and learning all these new technologies and trying to force all these new technologies into the product, you're wasting time, just to be flat
It's
out
true.
and honest.
Yeah.
For your own skills, absolutely develop those. But if you're working on a product for a company that is selling that product to people who are paying for that product, you're wasting everyone's time. I hate to be
No.
that blunt, but it
It
is as simple as that.
it's a good point. I do think, and to many of these, at the end of the day, your end users, they could not care less about anything that you do. They just want the thing to work. All right, Frank, what's number 2? Myth.
Number two, oh, I mean, I don't even want to say this one because I felt this way for so long. But in your summary, aim for maximum theoretical purity or pattern adherence. Oh boy, where to even begin with here? I think here's the problem. As developers, we all know there's 1,000 ways to implement the exact same thing. You give a
Mhm.
problem to 1,000 developers, and they're all going to implement it in a different way. And so at some point, there were some good ideas that, like, hey, here's a good way to implement this. Here's a good way to implement that. Here are some good rules of thumb that we should apply to that we should adhere to when writing software. And that's good because the space is so large. Constraints breed creativity, but constraints also breed, well, professionalism and quality at some point. But where it all falls apart is when you start forcing adherence to these rules of thumb and forcing yourself to, I don't know, what's the good one? The dry principle. Don't repeat yourself. Have you ever written the same line of code twice? I have. I've written the
Yeah.
same line of code twice a lot of places. And you feel dirty about it because you know if there's a bug in that line of code, now I have to change it in 2 places or 3 places. Or maybe I copy and paste it into another project. And then in another project, I realize, oh, geez, I fixed this bug. Now I have to go to 6 other things and replace those. There are excellent engineering reasons to not repeat yourself, but you can also waste enormous amounts of time by trying very hard to never repeat yourself. You can really paint yourself into corners. You can do all sorts of things like, well, just anti-patterns, basically. And it's funny because we are talking about patterns, object-oriented patterns. Remember the Gang of Four book? And I used to get this all the time, and I loved the enterprise patterns, and I was really into patterns. And I think patterns are a great thing when you're starting out and you're just getting your feet wet, or maybe you have never written enterprise software before and you don't know how to write a good plugin system. So it's good to see how other people write a plugin system. But at the same time, 100% adherence to any dogma, and that's what these really are. They're just dogma because there's 1,000 ways to implement everything. It's always going to drive you nuts and again, waste time. And again, the user's not going to care whether you followed patterns or you just copy and pasted every single line of code. I think that I use what I think you learn eventually over time through enough programming and enough experience is that these are all rules of thumb, but there are higher level rules of thumb that you want to adhere to. For me, my absolutely highest rule of thumb is this going to be maintainable by me for the next 5 years? That's the only thing I care about. So does the dry principle apply? Well, depends on the maintenance cost of that.
Yeah.
Am I using singletons? Well, depends on the maintenance cost of those singletons. Do I have 100% unit tests? It really just depends on whether I think those unit tests are going to help me in maintenance. So I think patterns and practices and all that kind of stuff, they are excellent to learn to help you narrow down the field and give you good pointers in the right direction. But at the same time, I think that I don't know. I think we should be striving for higher level rules of thumb to follow, and those are the ones you should be strict about, not these low level ones.
Yeah, when it comes to these myths, like kind of number two and number three kind of blend together in a way. And I think like when it comes to pattern adherence, like I think of MVVM specifically, right? And like an object oriented programming and MVVM, and like people like are want this purist, right? This purity of there's no there's no code in the code behind, right? It's all
Yeah,
data binding all the way down. And there's like so they create, create libraries and use these things and all this other stuff to like get rid of any possible thing. And it's just like, I don't know, just like do the button click and the code behind. Like just do. It
high
doesn't even matter.
command.
Like nobody cares. Just it doesn't even matter. Just do an icon, do a thing. You know what I mean? It's just call the method, do the thing, set the binding in the code behind. Nobody cares. Nobody cares who did it. At the end of the day, it does come down to maintainability, like you said, which is helpful. But then, you know, what does that mean, right? Like if you
Mhm.
pass in a view model into your constructor that's not using this thing and setting this thing in the code behind, like, oh no, you know what I mean? Like, what's the difference there? So I think
Yeah.
that's something. And like you said, there's one problem, many solutions, like you said. And there's always going to be something, right? So if you're an object oriented person, cool. If there's functional, cool. Like I don't
Mhm.
think you need to be like 100% strict, but it is kind of like to the first part of like the tech that you use, like the patterns that you use, like if you like it and it's good and you can do it is good. And it kind of like it falls into number three. So the number three myth is that you must adhere to Uncle Bob's clean code rules at all times, which, what he says, Fireship says, hey, there's some good things in this myth, which is like meaningful names, small functions, consistent formatting. But then there's other things like, which is like dry, like you said, that don't repeat yourself, which, you become too clean. There's too many interfaces. There's too many classes. You're too much time refactoring, like repository patterns, all this stuff. Right.
Yeah.
I do think, yes, at all times, there's probably a myth to that you don't need to do that. But there's probably just good coding practices that are in there. Like there's nothing worse than getting like a JSON blob back or like opening a code file and like you can't understand the code or what is being returned based on the names of things. Like when you see like T and W and W52 or like what like there's somebody understands what this is that built it, but it's not like readable by anyone that is taking that on besides that person, right? So, for example, like I think he makes a really good point in this dry process is I think it's okay to repeat code, right? And this is what he says, like you repeat the code, you perfect the code. Then when you figure out, okay, this code is in multiple places, maybe I should move it then, but don't lead with that. I think some of these things are that like, you don't need to lead with all of these different things all up.
Yeah. Yeah. And just to stay very confusing, I do want to go back to the purity stuff because
They blend.
they blend. But I think as programmers, we like consistency. And so we push for hard consistency sometimes. I love functional programming. I love functional languages. I don't use Haskell, but I kind of love Haskell. I use more intermediate functional languages like F sharp. And then I have to deal with a lot of people who make fun of my F sharp code because I will happily put some procedural code in the middle of one of my functional bits of code because I use both to where I think I'm getting the most advantage from both. So even though I'm using a functional language that I could write the app in a purely functional style, it's within my skill set. I know how to do it, but I choose not to because I know that it's just going to make the code uglier or hard to read, or I won't even be able to comprehend it in the future. So it's tough sometimes. You have that purity part because you want it. There's a part of your brain that's like, oh, I could rewrite this into I don't know, a recursive way, a mutually recursive way. Or, oh, I see what I'm doing here. That looks kind of like a monad from Haskell. Maybe I should break the monad out to be an explicit monad. Don't. There's a reason we have syntax and languages, and there's a reason procedural code makes a lot of sense to people. There's a reason object-oriented code was developed because it's easier to express some things in object-oriented code than it is in functional. And vice versa, it's easier to express some things in functional than it is in an object-oriented fashion. And I think that tendency for simplicity and perfection can really bite us in the butt sometimes. I always go back to MVVM. It was a fantastic solution for binding data to UIs. So we have a bunch of data, our model layer, we have a bunch of UI stuff, setting colors and shapes and all that kind of stuff. And we needed to get these two disparate worlds to talk to each other. Sure, you could write the code that explicitly talks between them, but that's a little bit ugly. So we developed this thing called binding. Binding's a little bit weird too. So it would really help to have a middleman in this, the view model in the case of MVVM. And that was great. It was a fantastic solution to a very well understood problem. But then button click came up, and people were like, well, isn't button click just another transport between the model layer and the UI layer? Shouldn't I put the button click inside the view model also? And then the command pattern was developed. And that's where this simplicity of thought can really start to hurt because implementing command pattern is much more difficult than implementing a straight view model. View model is a very basic idea. Commands actually get very complex because you're working with two-way communications and it's procedural versus declarative, which is what the view model is. And so I think that tendency for purity can really waste a lot of time. I see so many people trying to jam solutions into the I command pattern. I'm just like, yeah, like you said, just do a code behind. It's going to be fine. Life will move on.
I totally agree. Like I've been doing the Blazor stuff, and yeah, you just like it's like on click, like just call this method and pass all these
Yeah,
parameters, and just like you just
they
write the
ditched
code in
it.
it. They did. It seems nice. Okay, what's myth number 4 that Fireship says, Frank?
Oh, this one I'm gonna get in trouble for because I have a lot of opinions also, but a 100% code coverage, and I'm gonna go so far as to say also test-driven development. Maybe it's not as important as we all think it is. And there's a lot of ways to come at this. If I'm writing a mathematical engine that has definitive answers to definitive problems, unit tests are a very powerful thing. Getting 100% coverage to make sure I implemented the addition operator correctly. Well, that'll never happen. You'll never be able to get 100% coverage with that. But there's this old Dijkstra quote. Um, Tests will only prove, sorry, tests will prove that I'm going to summarize it because I'm going to totally butcher it if I don't summarize it. But tests can only show that the bugs that you know about aren't in the code. It's only the bugs that you do know about. Tests are never going to prove that the bugs you don't know about aren't in your code. It'll never prove that negative. And I think that a lot of beginner programmers, which is good. They're learning to write tests and they want to make sure that they're actually testing important code. So you start to look at your code coverage numbers. That is a good practice. Keep that up. Code coverage is a good thing. 100% code coverage is not necessarily a good thing. Testing every possible error path, even though it's important if you're writing something like human critical. I was once writing steering gear control, rudder control for battleships. These are ships out at sea, and people's lives are in danger. If I have a bug in the code, I can put people's lives at risk. For that, I feel like, yeah, maybe I actually do need 100% coverage because maybe I do need to handle, and the 100% coverage is usually the error paths that are hard. And I wanted to make sure I actually was covering the error paths. So there's a time and a place for 100% code coverage. But for a UI application running on iOS that queries like fairy times and things like that, 100% code coverage, it's never going to be what you think it is. It's going to take a lot of time to get that 100% mark. It's only going to prove that you don't have the bugs that you think you have. I think I phrased that poorly, but you know what I'm talking about.
Yeah.
And I think the YouTuber said something very important here, which is it gives you a false sense of security.
Yeah.
You see that 100%, you're like, well, my code's perfect. Your code's not perfect. I promise you, your code is not perfect. Hand it to a tester. Also, this I should say, developers are the worst testers on the planet. And that comes down to unit tests also. If you have a second person who's only writing unit tests and their job, maybe their paycheck depends on them finding bugs in your code, guess what? You are going to be fixing that code for the rest of your life because you pay people to test software, they are going to find bugs and they are going to keep finding bugs. So, whatever your 100% code coverage is for your tests, you're lying to yourself and you're creating a false sense of security. Uh, this is a bit of hard wisdom because unit tests are important and it really depends on the application. But that 100% code coverage thing is just one of the worst myths I've ever seen.
Yeah, I agree. Like, he says high quality or high coverage does not equal high quality. And that's totally correct. There's so many other parts of the scenario too. Like, when I worked at the game studio at Crunch Time, like we had a dedicated game tester, and like that dude knew how to test and break everything all the time
Testers
because
are amazing.
yeah, for me, like often in my code, right, that I'm running it's the happy path, right? Like here is the thing. And like it's like it's either going to deserialize the JSON or not deserialize the JSON, right? Like either one way or another, right? So there's like that aspect to it. It's either going to work or not going to work. But I agree. Like I think the other part is like here's a good thing where like 100% code coverage means nothing. I have my feedback app that I've been working on, and I just implemented some new like blob caching like in the back end, the function. But I didn't really care for it to like run the timer trigger locally, like at all. And then like the method, I just didn't want it to be exposed because then I need like, different servers and stuff running. So I said like, pound, if if debug and, and storage and, and
Yeah.
storage. And then like I did it. So I turned it on. So that way in debugging, it wouldn't turn on. Well, what I forgot was to put or release. So like I just
Okay.
basically commented out the code all the time. So like all my unit tests passed and everything like was great, like because I had like the certain debug flags on, but like when I pushed to production, oops, like I went to use the one piece of the functionality and it's like 404, like this thing doesn't exist. I was like, oh, because I literally commented out the function and like no longer exists. Oops. You know what I
That's
mean?
a
So I could have 1,000% coverage, but it doesn't matter if I didn't push it to production correctly or just commented something out. It's just ridiculous. So something like that is there too. And I think often, for me, I'm not a tester. Like I'm not if people that know me, I don't believe in testing, but I'm also not creating mission life-saving software. I'm putting numbers on a screen that's either going to connect to a Bluetooth sensor or not, right? Like it's either going to grab the YouTube comments or not and analyze it, right? So that's how I feel about it. Now I do have some unit tests because Copilot wrote some unit tests for me. That's great, and Copilot's going to definitely write. It's going to definitely write
more.
unit tests that pass because like it
Yeah.
wrote the code in general, right? So that is also like it's also this false sense of security, right? Oh, I have like 20 unit tests. That's great, but is it end to end? Is it functional? Maybe some playwright tests would have been better. Like I actually click on a thing and do a thing and something returns. That's probably better than some of the stuff that's out there. So.
Yeah, no, I want to stress that it's easy to write passing unit tests. Where things fail is always in integration or end to end, as you put it.
Mm-hmm.
Um, my very first job at General Motors was we used to write tests by hand. It was a Word document, and someone would propose a set of inputs, propose a set of outputs, and then by hand I would go through, read the code, decide using my own brainy brain what the outputs should actually be, and then maybe we would run it and that kind of stuff. But we proved the correctness of the code just using our little brains. And I had a binder, just hundreds of pages of these kinds of course, we printed them out. This is back in the day. And it was one of the most thoroughly tested pieces of software I had ever seen in my life. And I was quite confident about all of our unit tests. But we put it in the car and it kept breaking. It broke here, it broke there, broke all over the place. And that's because we weren't doing integration tests. Our unit tests were so confined to the code and these functions that we were missing the forest for the trees, basically.
Mm.
And it's the TDD agile obsession with unit tests. Unit tests are good. Unit tests are definitely needed in a lot of places, but they never give you a full picture of how your software is going to work. Like you said, you at some point you just want to click a button and see that a dialog box comes up. That's what's important. It doesn't matter if the unit tests pass or fail. That dialog box needs to come up.
Yeah.
So I don't want to like come off on this podcast like we're just bashing testing left and right. But
No, no, no.
you gotta know the limits of it. And unit tests are incredibly limited for all the reasons we just stated.
No, totally true. I totally agree with you. It's a lot. All right, number 5 myth along those lines is that, Frank, the myth is that you should always optimize for performance all the time.
This is correct.
No, it's I knew
This
you
is
were going to
correct.
say it.
Okay, look. I am a performance freak, so I do prioritize performance over a lot of things because in my mind performance is a feature, and oftentimes it's a distinguishing feature. A lot of times your competitors have the same feature that you have, but if you can make it 10 times faster, time is money, baby. Like it matters. Compute time on the server, that matters. User time, that matters. Compile time, all that stuff matters. That said, like all things, everything in moderation. Don't obsess over one thing. Have some unit tests, have some performance tests. Don't obsess over the performance tests over the unit tests. You want to find that nice balance in your life. So I do want to, I want to argue about this, but in the end, it's just all the things we said bad about unit tests. You can say the same thing about going for the ultimate in performance. That said, I am slightly more biased towards the performance because I truly do see it as a feature, and it opens up a lot of things that you can do if you have efficient code. How do you feel about performance, James?
Um, I have mixed feelings on performance. I I think that you don't need to necessarily lead with performance. I think he makes a great point that like your users, I think he says, you know, your 5 users of your website probably don't care, you know what I mean, type of thing.
That,
Uh,
yeah.
I think he also says that about says about a lot of these facts, but also like if something takes a quarter of a second compared to a half a second, that's not that big of a thing. Like I think it is micro optimizing, and that's what I think is to me optimizing code. Yeah, like that's probably pretty decent just for even like maintainability. Example, I had this method called clean markdown. And what I was doing is I was passing the analysis of this feedback into my text to speech engine. Well, I didn't want it to read hashtag, hashtag, H2 header or whatever it is. You know what I mean? I wanted to clean the markdown. So I asked it to write a method. And the first time it wrote a method, it just simply created all of the regexes inside of the static method. So it was creating 20 regexes just every single time you call this thing.
Mm-hmm.
And I was like, well, this code works. It's definitely fine. I don't really know what each regex is doing necessarily. So I asked it to refactor. I said, can you optimize this code and make this like compiled regexes, like not in the
Mm-hmm.
class? And like, that was a good optimization. I was like, you move the regex creation outside, right? Like maybe use a string builder and, these other things. So like that was like a little bit more beneficial in that realm of things all up. So that was like kind of something that I was recently thinking out. But that being said, you should probably over scrutinize performance on the things that need the scrutiny of the
That's it.
performance. That's the important part.
Yeah, and the best way to do performance is to, before you even start thinking about performance, have a rough idea in your head of how you want it to perform. When you click that button, should it respond in less than a second? Or is it okay if it takes 5 minutes? If you're uploading a 10 gigabyte file, it's okay if it takes 10 minutes. That's fine. But
Exactly.
if it's a button the user is expected to click 30 times a second, well, it better respond in 1/30th of a second. That's just how it is. And so
Mm-hmm.
you write whole books on performance. Always have expectations before you do anything. Always measure, because the things that we like to work on as programmers often aren't important. Like you pre-compiling that regex, I bet you in the end it really didn't make too much difference. Might have
No,
cost you a few. No.
no, didn't matter.
No. But let's say you're writing a game engine, and 60 frames per second, you're writing a Twitch shooter, you got to be quick. It matters that everything's getting processed in 1/60th of a second.
Yeah.
Meanwhile, if you're writing, say, a circuit simulator, 1/60th of a second, that's slow. I need to run things. And I need to run things 100,000 times a second in order to get a decent simulation out of some things. So I have to write code that is doing zero allocations, that is just barely doing any computation per step, because it needs to do that 100,000 times. And we have processors that run at gigahertz. So, we're just pushing the edge of what you can do. And it matters in cases like that. But if you're not writing a if you're not writing simulation software, if you're not writing a game and you respond within a 30th of a second, that's good enough. There's really
Yeah.
no need to optimize the regex beyond that.
No, that makes sense. Makes sense. I like it. Yeah, that's really what it is. Like use patterns where patterns make sense. Optimize where optimization makes sense. The next one, you should always optimize
Same.
for web scale. Kind of maybe when it makes sense. I mean, I think he talks a lot about like serverless and microservices and scaling. People talk about Docker and Kubernetes and all these other things. Like everything sounds really cool, but to me, it's perfectly the same. Like my little web app that literally, I was thinking about this because I was like, okay, I'm having an app service. I'm like, okay, have some
Mm-hmm.
functions are going to scale. Like, actually, I didn't even need to do any of my logic inside the functions. It didn't really provide that. I could have just literally put it inside of the Blazor server app because like it's running on the server, right? I'm just having my
Mhm.
server call another server, which is totally fine, which is also legitimately okay. But like, should I have gone down that complexity route in the beginning, assuming that, oh, what I'm thinking is today my website's going to have, but what if I have MCP servers? What if I have other clients? What if I have this other client that everyone needs to hit these functions? Well, then I could just do that then when that happens, right? Like, I don't know if I need to
Yeah.
optimize it for that right away. And that's like a very small web cloud optimization. You know what I mean? At the end of the day. But again,
Yeah.
my 10 users, I added Azure Monitor to it. And it's like, it's like up to 3 users, maybe over, maximum over 1 hour during the day. Like, okay, I think it's going to scale just fine.
And honestly, there's a lot of hacks to scale. You add a simple caching layer, and you'd be amazed how you can scale some things. Even if you have like an AI service that's taking arbitrary queries from users, you'd be amazed how many people ask the same question out of
Yeah.
something, and you can just cache that away. Yeah, maybe the cache will only hit 20% of the time, but that's a 20% improvement you just got for basically doing nothing, just
Yeah.
adding a simple layer of caching. Web scale's tricky because this space changes all the time. I really believe with modern machines, though, PHP and Postgres running on a server can serve so many people if you don't write the code in an absolute terrible way.
Mm.
But at the same time, life has even gotten easier. I have several web services that I would say that I've over engineered because maybe I have the database as a Docker file, the front end as a Docker file, and then maybe like an API as a Docker file, essentially 3 machines. But because I architected it that way as Docker files, I can run all those on physically 1 machine. And it does fine. It has no problem running those 3 servers. It's not three
Yeah.
servers. But should I ever get the 10 million users per month that I dream of and make all the ad revenue and retire early, I know in the back of my head I could turn it into 3 machines. And then I'm going to get a huge amount of scale out of that. And then if I ever break that number, well, then I'll just hire someone to scale it up for me after that. As they say, if you have too many users hitting your service, that's kind of a good problem to have because
It's
if
very true.
you're monetizing correctly, you should be able to like hire someone else to handle all the performance stuff for you. Or it's okay if you take a week and re-architect it to be more performant. Um, I see this all the time on the web. Um, the web is so trivial to program for. Just put up one server and just do everything.
Yeah. An app service is totally fine. That's like at the end of the day, I right click publish. It's good to go. You know what I mean? Just saying.
Well, James, there's one last big myth on here. I don't know. Is it a myth? I think maybe we'll have a little bit of discussion on this one. But how do you feel about the statement AI is about to replace all programmers? How do you feel about that?
I mean, no. I mean, I think it'll change how we work as programmers. That is for sure. And through the entirety of the pipeline from, to thought to implementation to maintenance to release to feedback on it to analysis to help us diagnose things better in general. Um, there's tons of great tools, right? And I use Copilot all the time in VS Code and in Visual Studio, and obviously I work on Microsoft, so I'm biased towards our tools. But like, it's a pretty huge time saver. I really love it. And like we talked last week for a half an hour of how I vibe with it. And when I say vibe coding too, like I'm just coding. By the way, like
Having
I'm
fun.
just
Yeah.
coding with it. Like there's different thought processes of the vibe coding as like, oh, vibe coding, I'm just going to spin up this new thing, this whole thing. I'm actually working on like a real thing. Like this is a thing that I put onto the internet. Like I'm adding new features, I'm refactoring it, I'm doing stuff, right? And to me, that's all vibing because I'm just communicating and understanding how it's working, and I'm reviewing its code in real time, just as if I was to write it, right? And sometimes I tweak it and modify it and do stuff like that. I do think he does make some points like AI is pretty verbose, right? That, are we relying on it too much? And the answer is like, actually, I don't think so. Like, I think when I look at the code, that when I look at the majority of the code that I write with Copilot, whether it be with Sonnet or with GPT-4.1 or with whatever the things are, whatever model I'm using, Ghost Text, most of the time it's code that is either relatively similar to what I would have written or kind of near identical, or sometimes if I had more time, I would write this overly architected code. For example, I recently, just before I left work today, I was like, oh, I have there's this like little toast and that comes up when I save or whatever, on the setting screen. And I was like, oh, I'm looking at the code that it generated. I didn't even review this code. And literally, like in line, like in one long line of text, it's invoking JavaScript to do a pop-up. It's like so long. And I'm like, that's weird. I was like, hey, can we just like refactor this toast and like just put that JavaScript? This is what I said. I said, put that JavaScript into a JavaScript file and then just invoke from there, right? Just still have the invoke file. And it's like, hold on, bro. I know what you really want. Because I read your custom instructions. It told you really like these patterns and practices. You like components, you do this stuff. So it first moved all the JavaScript in there, and then it created like a whole toast class, and then it created a toast component, then it created toast extensions, and it made it so I could say like toast dot show warning, and it would just do a thing. And I was like, you know what? This is actually kind of how I write my code, maybe a little bit too verbose, but actually like, not bad. But I was like, I probably wouldn't have written this if I wasn't using the tools as is. Now, of course, I reviewed it and I, cleaned it up to how I like it with it. But I was like, actually, it kind of like did it better than I did. And I said that the thing that I think I really appreciated about it is it can write CSS way better than I can write CSS.
Yeah.
So is it going to replace my CSS writing? Yes. I never want to write CSS ever again, Frank, ever in my entire life, basically. But beyond that, like the actual code, I'm like, it's not too bad. You know what I mean? So I'm really enjoying it that. But I do think, to his point, there are great tools and you could waste time on it. Like there's definitely the instances of like, I've gotten down some path where half an hour in, I'm just like, I don't like any of this. Just delete it all. But then I thought to myself, how many times have I done that myself? How many times have you just have a branch of code that never gets merged in?
I have whole projects.
Exactly. It's just coding. It's just coding. So no, I don't think that AI is about to replace all programmers at all. Like I think it'll change how we work, and it already has to some extent, and it'll continue to evolve. And you'll choose, it's a dial. You'll choose how you code and more or less. I think we've talked about it, you and I, is like you seem to really like, Frank, like using a lot of Copilot in Swift and in Xcode, right? And maybe less so when you're doing F# programming or C# programming, just like based how you work, right? So you'll use the tools based on what you need to do, right? So I think that's kind of how I see it, and just it'll infuse in other aspects of it. Like I sure would like if a deployment went wrong that someone would recommend a fix for like whatever I broke in it. You know what I mean? Like figure that out. Like, oh, the build is broke. Like imagine you're like, oh, I pushed code and then it no longer builds my CI. Like I'm just, someone fix that. Like just give me a recommendation. So that would be nice. Just saying, save my time.
You just brought something up that I was going to say for the end, but I'll just say it at the beginning. I think in a lot of ways, programmers are going to be able to charge a lot more in the future because people are going to create these messes of AI code. And when it breaks, they're not going to know how to fix it. And they're going to need a specialist to come through and read the 100,000 lines of code the AI generated, gain an understanding of it, and fix it. Sure, someday the AI might be powerful enough to do that, but we are not there today. The AI thing, no, it's definitely not going to replace all programmers, but it is going to replace the menial jobs, the junior programmer position. So it's going to be harder and harder to be a junior programmer because until your skills are at least competitive with the AI, why would anyone hire you and pay for you? The AI is cheaper. I look at this purely from a business standpoint. Some businesses just need simple code written en masse. And for that, those businesses will be able to take advantage of AIs and maybe they will lay off some programmers. But programming is a solution looking for problems. So it really is the problem dependent and business dependent. If you are writing a new system for doing some very novel idea, maybe you're breaking into a new science frontier, implementing something that's never been done before, or maybe just like an original game mechanic, that part of programming's going to survive into the future. We still have carpenters, even though we've had CNC mills forever.
Yeah.
There are still carpenters. I hope programming will never become that niche of an area where it becomes mostly a hobbyist activity. But I really do believe that um, highly skilled programmers will be, for at least many more years, will still be in demand. I do feel bad for the junior programmers out there because you need to get your skill level up beyond vibe coding as quickly as you can. And in that case, you just either have to vibe code more than everyone else so that you can gain that expertise and skill,
Yeah.
or you just got to read more books, enter programming competitions, whatever it takes to stay ahead of the AI curve. It's going to become harder and harder, though, to stay ahead of that curve. I'm lucky. I think we're both lucky. We're a little bit old into this thing. We've gained most of our skills. Hopefully, they won't surpass us within our feasible working futures. I don't think they will. It's possible they will, but just looking at the growth curve that we're at right now, AI programming's already hitting a plateau. I mean, you can just watch this podcast, listen to this podcast, watch and listen, and see like where we started. I remember when I was working with GPT-3 and I was generating XAML, and it was
Mhm.
horrendous, and you could barely get it to generate any kind of XAML or any kind of UI, but I was still very excited because I saw the potential of the future there. And we were very low on the hockey stick curve. We're now about midway on that. It's not a hockey stick this time. LLMs have limits, so it's more of an S curve. We're about halfway, I would guess, on that curve at the moment. So I would guess that yeah, the low level menial labor jobs will kind of disappear. But I think that's all the more reason, if you have any interest in this subject, to just push yourself to become better than the AIs are right now. And I want to go back to what coding really is. Coding is taking human problems and getting a stupid machine to solve those problems. We are encoding information, we are encoding processes. And that human element is just going to become more and more important. If someone has to write 100,000 pages in order to get an AI to write the program, well, maybe it's easier to have a 2 hour meeting with a human being that has enough experience and knowledge to fill in the gaps of um, the full requirements of the app. No one writes functional specs, especially after the agile revolution. No one writes functional specs. But with the AIs, people are basically writing functional specs for their apps. They're doing it in an ad hoc, terrible way through a chat UI for whatever reason. And that is not an efficient process. An efficient process is to find a game, let's say I want to write a game, is to find a game developer who has experience writing games. And you sit down and be like, I want a game with this guy that wears a red hat and he jumps on turtles and sometimes he goes down some pipes. And the game developer's like, I'm on it. I know what you need. So you don't have to write the 100,000 page functional spec. And I think it's, again, just expertise. And that's what people will be seeking out more and more in the future because no one wants to write a novel to get a piece of software out there.
That's true. I think that calling them like kind of like mini specs and micro prompts and things like this of like standardizing the way that you communicate with these are just evolving, right? I think that's the other part too, is like you kind of said earlier, is like back in my day 2 years ago, like when you were generating some XAML, you're like, oh, this is cool, right? And then things evolved, and then things that started to evolve faster and faster and faster, and now to the point where like, wow, it's actually like in this really cool state where like I can do these specific things and I can be more productive, but like I'm still understanding and in control of this tool. It's just another tool in the toolbox, right? Just like the first time we saw like IntelliCode and like the
Mhm.
IntelliSense stuff light up and all these other things, like, oh, this is amazing, right? Um, and I think it's just like, in Visual Studio, just refactoring and auto doing stuff. Like a good example is like there's a lot of tools that you need to use as well, and like mastering the tool that you're using can also be productive too. So for example, like Visual Studio, like you can like right click and say, remove unused using statements. Like you could ask
Mhm.
the AI, and I've done this, hey, can you go examine this entire code base and like remove namespaces that aren't required? Like That AI
Mhm.
got to do a whole bunch of work. You know what doesn't need to
Mhm.
do a bunch of work? Visual Studio that's been like finely tuned to do that operation, right? That's
Yeah.
there. So mastering that time saving thing is a lot. It's like, hey, this is a time saving thing. Right click, remove all things, compared to do this thing that's going to take like 10 minutes for it to analyze your code base, right? So as developers, we need to use the tool when using the tool makes sense and being optimized there. But I actually am not too worried about the junior developers, to be honest with you, because I think junior
Okay.
developers have this opportunity to unleash creativity, right? Like I think that's another
Mm.
part too, is like there's always opportunity for innovation, right? There's always going to be some new coffee machine. There's going to be new some camera. There's going to be new some microphone. Like we're still evolving the microphone. Like how? There'll be new lights. There's going to be new mug technology. There's going to be new, cell phone. Like there's always going to be new innovative things that are like, oh, I never thought about that, right? Like, there's an idea that didn't even happen. Someone has to have the idea, and then you have to be able, of course, to get from idea to completion. And some of that's going to involve AI, and then some of it's not. So it's kind of where you're at. That's how I think of it. So I think those junior developers obviously should up ramp and understand, and maybe even learn some of the myths that we talked about above. But at the same time, get innovative, do some funky stuff. That's what I say. Get weird with it.
Okay, you said weird, not vibe, so I'll give you that. Yeah,
Yeah.
creativity. I'm just so afraid of that word when talking about this subject, but yeah, you nailed it. Um, so far, we haven't been able to, I haven't been able to sit down to a chat prompt and say, "Build me a business that makes me $10,000 a month." Go.
What?
So
No
far,
way.
so far, it still doesn't quite do that. I mean, I'm
Yeah.
working on it, but you know, um, it's still understanding business needs and understanding markets and understanding human problems that can be solved. Those are all human endeavors right now, and those human endeavors will be encoded into silly little programs with funny little widgets for
Mm-hmm.
quite a few years more. Maybe in 200 years, though. I'd love to hear the conversation they're having in 200 years.
Yeah, totally. All right, Frank, that's going to do it. 7 myths. We did it. Only took an hour for a 6-minute video.
I was going to say that a little bit of expansion of time, huh? And I really hope we didn't sound too down on any of these things because everything we discussed here are good practices,
Yeah.
honestly. So we just gave the counterpoint to all the good practices, and so did the video. And I think that that's needed. You don't want to get into your little bubble and stay in your little bubble. You got to always think of it from the
You
outside.
know, and Fireship had the escape, right? Which is like often a lot of these myths are like, you have to aim for, you need to use. Like those are finite things, and like that's not how that works, right? So I think
Yeah,
it's a fun video to analyze to get it's basically what do we think of these 7 different topics, and do we think how
yeah.
far down the rabbit hole should you go? But like at the end of the day, hey, you're you. To do what works for you. That's okay. Be
If you love
yourself.
performance, man, make the fastest compiler ever. That just someone's gonna buy
Well, and
it.
then go work on the performance team of like the .NET team. You know what I mean? Like
Yeah.
like what they care about is performance, right? It's like that's all we care about. Go do, if that's what you care about. Go do that, right? Yes.
Yeah.
All right, Frank, that's going to do it for this week's Merge Conflict. Thank you so much for breaking down these myths with me. You can check us out on YouTube. You can do a react to our react video at youtube.com/mergeconflictfm. You can find us there. You can subscribe in your favorite podcast application. You can also become a Patreon member where, yes, this week we talked about more dongles. So if you want more dongle goodness, over to patreon.com/mergeconflictfm. But that's going to do it for this week's Merge Conflict. Until next time, I'm James Montemagno.
And I'm Frank Kruger. Thanks for watching and listening.
Peace.